title of this note is Inverse Functions. And the objective for this note is to be able to calculate the inverse of a function 3 ways: numerically, algebraically, and graphically. So first of all, what is an inverse function? An inverse function is one that goes backwards. So normally we have an input, and then the function takes the inputs into an output. So you usually call our inputs x, and then we have some rule f, and we have a bunch of outputs called f of x. An inverse function is going to go in the reverse order. It's going to take the outputs, send them back to the inputs. So the notation for this is that -1 exponent. We read this f inverse of x. And we've seen that -1 notation before with matrices. It means inverse. So f inverse of x is going to take the outputs, send them back to the inputs. So the first type of inverse function we're going to calculate is a numeric function inverse. So let's say I have some function f, and I'm just going to define f as a bunch of points. I'm using my curly brackets, and let's say 1, 0 is one of the points, maybe 2, -3 is one of the points, and 4, 5 is one of the points. So there are only 3 inputs in my function. The inputs are the x values. What the inverse is going to do, it's going to reverse my input and output. So my first point will be 0, 1. My second point will be -3, 2. And my last point will be 5, 4. So all you're doing is you are reversing x and y, because they switch. Instead of going from x to y, you're going backwards. You're going from y to x. So what's that going to look like on a graph? So let's graph a function. Let's graph y equals, let's do 3x. Y equals 3x. If we were to graph that function, it's a line going through the origin with a slope of 3. And we know a couple points on this graph. We know that 0, 0 is on this graph because 3 times 0 is 0. Just put a few points here. Here's 0, 0. We also know 1, 3 because 3 times 1 equals 3. Input, output. We also know 2, 6. And how about a negative value? Let's do -3, -9. And I know that because if y equals 3x, 3 times -3, the output will be -9. So there's a couple points. Now think back to what we just did on the last page where we did a numerical function inverse. We're just going to switch x and y. So on our new graph, we need the point 6, 2 because we are switching our x and y. So I'm just sketching here. Let's sketch 6, 2. We also need the point 3, 1. So obviously 6, 2 should be a little bit higher than 3, 1. So I'm just going to kind of move that up some, move that down some. All right, we also need 0, 0. And if I switch this x and y, I will get -9, -3. So that's over here. And if I connect these points, I'm going to see I get another line. So the inverse is still a line. I've switched my x and my y. What if I plot this on the same graph? I'm going to take this line over here, and I'm going to plot it over here so you can see it. What's really happening is there is a reflection. If I could fold my graph, how would I fold it so the green and the blue lines end up on each other? If I fold it along this red dashed line, the green and the blue lines will be on top of each other. I have a reflection over that red dashed line. That line happens to be y equals x. And this is true for all the graphs. There will be a reflection over the line y equals x in your graph. So you can use that fact to quickly graph any function. So let's say I have this function here. Okay, I don't even need to know what it's defined. If this blue function is f, and I want its inverse, I'm going to think about the line y equals x. That's y equals x in red. And I'm going to reflect the blue over y equals x. If I reflect it, it looks like that in green. And that is called the inverse. And I can do this for really complicated graphs if I wanted to. I could have a function that goes up and then down and then around like that. Doesn't that look exciting? All right, so that blue graph is f. Let me label it as such. I want to know its inverse. So I'm going to draw my line of reflection, and I'm going to fold, and I'm going to do my very, very best to reflect this thing over the green, over the red line, and I'm going to put it in green. So it's going to look like this. Okay, it's reflected over the red line, and if I were to fold it, I have these points over here matching up. This point matches up to this point. If I fold it, this corner matches up to that corner, and likewise. The very last type of inverse we'll have to do, and where we're really going to spend most of our time, is on an algebraic inverse. So there are a couple steps here. If I give you an equation, how do you find its inverse? So the key here is that you're going to interchange x and y, and you're going to solve for your new y. So let's look at an example. Suppose that I have a function f of x equals 2x plus 7. And I want to find its inverse. So what the very first step is saying is saying just, hey, instead of using f of x, let's just call this y. This is a y now. And I'm doing that so that my second step is really easy. I can interchange my x and y. So when I interchange x and y becomes x, and x becomes y. Everything else stays the same. This is happening because the definition of an inverse is that your inputs and outputs are switched, and input is x, output is y. So your x and y's are switched. Once you've got this, you're going to solve for y. Okay, doing basic algebra. So first I'm going to subtract from both sides. So I have x minus 7 equals 2y, and then I'm going to divide by 2. So I get that y equals x minus 7 over 2. If I could simplify, I would. And then the very last step is just about the notation. It's saying replace the y with the notation f inverse of x. So if the function is 2x plus 7, its inverse is x minus 7 over 2. I could confirm that graphically. I could put one of these functions into y1 on my graphing calculator, and I could put the other function into y2. And what I'm looking for is that when I see their graphs, I'm going to see 2x plus 7 is going to look something like this. And then x minus 7 over 2 is going to look something like this. And what I'm going to notice is that they reflect over that line, y equals x. This is it for our notes. Go ahead and draw your line for your summary, and come in ready to practice inverse functions.